Across the globe, a new age of connectivity is dawning. Thousands of satellites launched by companies like SpaceX promise to bring high-speed internet to even the most remote corners of our planet. This ambitious endeavor, known as Starlink, has captured the imagination of many. Starlink aims to bridge the digital divide, connecting people and fostering communication like never before. It's a vision of a future where geographical barriers no longer hinder access to information and opportunities. The potential benefits are vast, from revolutionizing education in developing countries to enabling scientific research in remote areas. However, this technological leap forward comes with a hidden cost, a threat to the very atmosphere that protects life on Earth. As these satellites reach the end of their lifespan, they re-enter the atmosphere, leaving a trail of aluminum oxide in their wake. This seemingly harmless byproduct, as we're about to discover, holds the potential for significant damage to our planet's delicate ozone layer. Starlink satellites, like many others, are primarily constructed from aluminum. While durable and lightweight, this choice of material has unintended consequences. As these satellites re-enter the Earth's atmosphere, they burn up, releasing aluminum oxide particles into the mesosphere, a layer high above the Earth's surface. These particles, though microscopic, are not without their dangers. Research has shown that aluminum oxide can act as a catalyst, accelerating the destruction of ozone molecules in the stratosphere, the layer below the mesosphere that shields us from harmful ultraviolet radiation from the sun. While aluminum oxide doesn't directly deplete ozone, its presence amplifies the destructive potential of other ozone-depleting substances, such as chlorine, still lingering in the atmosphere from past human activities. The impact of a single aluminum oxide particle is significant, capable of destroying thousands of ozone molecules over several decades. The influx of aluminum oxide into the atmosphere is not a hypothetical concern. Research indicates that atmospheric aluminum oxide levels have been steadily increasing, coinciding with the rise of large-scale satellite constellations like Starlink. This trend is deeply concerning, as the full impact of these particles on the ozone layer won't be felt for decades due to the time it takes for them to descend from the mesosphere to the stratosphere. The lack of comprehensive regulations governing satellite re-entries exacerbates the problem. Currently, companies are granted permission to launch thousands of satellites without adequate consideration for the long-term environmental consequences. The absence of a robust regulatory framework allows for the unchecked accumulation of aluminum oxide in the atmosphere, potentially jeopardizing the fragile recovery of the ozone layer. The consequences of inaction are dire. A depleted ozone layer would expose life on Earth to increased levels of harmful ultraviolet radiation, leading to a rise in skin cancer rates, cataracts, and weakened immune systems in humans. The impact on ecosystems would be equally devastating, disrupting marine food chains, damaging plant life, and altering delicate ecological balances. The challenge before us is clear. How do we reconcile our technological ambitions with our responsibility to safeguard the planet? The answer lies in a multi-pronged approach, involving innovation, regulation, and international cooperation. Satellite manufacturers must explore alternative materials to aluminum, materials that pose less of a threat to the ozone layer upon re-entry. Additionally, designing satellites for higher graveyard orbits, where they pose minimal risk of atmospheric interaction, could be a viable solution. Furthermore, robust international regulations are urgently needed to govern satellite deployments and re-entries. These regulations should mandate environmental impact assessments, promote the development and implementation of sustainable technologies, and establish clear guidelines for mitigating the risks posed by satellite debris. The pursuit of technological advancement should not come at the expense of our planet's health. We must act now to ensure that our quest for connectivity doesn't inadvertently unravel the delicate threads that hold our atmosphere and indeed, life itself, together.